Hey everyone, I'm Max. Let's learn how to tackle this educator question, sortable. This one is pretty easy. It's essentially just making a bunch of different calls to the standard sort function. If we take a look, this will help us quite a bit with solving this problem here. Sort, let's look at its arguments. So it, it gets passed in a first and last iterator, and then a comparator function, right? Which returns a Boolean value, and that's actually used to order the elements that are being sorted. And you can see that, sorry, there's like people outside. You can see that we actually order the values in between these first and last iterators, with first being inclusive and last being exclusive. So by default, right, when we call sort, right, what we would do is something like this probably. We'd say sort nums dot begin, nums dot end. Dude, the computer is really slow right now. And then that's that. So what it is doing, remember, nums dot begin points to the first element in this case vector, right? Whereas nums dot end points one after the last element in the vector. So we want to include this first one and exclude the second one. Here, because we want to sort in normal order, we don't have to provide a custom comparator. We'll do that in a second. So here, let's work on sort first half first. So if we want to sort the first half, obviously we want to start at nums.begin, right, that first element. But we want to end not at nums.end, the very end of the array. We want to end at kind of halfway through the array, right? So what we can do is we can start at the first element and, oh my goodness, yeah, and add half of the array's length, right? Now let's be careful here. Nums.size over 2. Remember that this one's excluded, and it says here that if the vector size is odd, we should not include the middle element. So let's think about this case, right? 6, 5, 4, 3, 2. Odd, obviously. So we just want to sort these first two elements. Now, nums.size will be 5, and if we have that, we get 2. So nums.begin will be incremented by 2, right? 1, 2. Now remember, this ending iterator is not included in what we sort. So we'd only be sorting the first two elements. That works. Now, here, what if it is even, as it was? In this case, nums.size would be 3, or nums.size divided by 2, my bad, would be 3. We start it here, and we increment it 1, 2, 3 times. Again, we'd get that second half of the array, which again, this starting is excluded. So we're just sorting the first half. So that actually looked good by itself, just by having the size. And then that's done in place, so we can just return nums. Now, sorting the second half, going to be very simple. Obviously, we want to end at nums.end because that's what we would if we were sorting the entire array. And it's really where we start that we want to change it up. Now, we've already coded for sort first half. And we know that sort first half does everything up to this value, right? This is the first value in the second half, as per this definition. So this is the first value in the second half. And remember that this is exclusive, right? Sort first half did not choose to include this element. Now, sort second half wants it. And nums.begin just so happens to be inclusive. So if we pass in this, nums.begin, or sort second half will actually sort using that element. So that like 3 that we talked about earlier will actually be included because remember this first argument is actually inclusive. So that literally just pasting that over will do exactly what we want it to. All right, sort reverse. So here we obviously want to pass the entire vector into sort. But here, instead of sorting from least to greatest, we want to sort greatest to least. Now, remember, we can change the comparator, and what we need to do there is we need to return a function that returns a Boolean, right? Easiest way for us to do this with this very simple implementation we're just doing here is to use a lambda expression. Don't get scared. I'll go first in a second. This is all the lambda expression is, right here. That's all it is. So basically, again, we're not capturing anything from the outside. We're just taking two values, right? A first and a second. Now, if we return true here, we're essentially saying, I want the first element, this first one, to be prioritized. I want it to come first in the resulting sorted array. So you can imagine that a normal sort from least to greatest would do something like this, right? Where it returns true if the first element is less than the second element, because that means we want the first element to come first. However, in this case, again, we want to sort in reverse order, which means that we can actually make it this less than into a greater than symbol. So again, we return true if the first is greater than the second, because that means we want to prioritize the first. We want that first to come first. And we return numbers. Now, this one here, sort structs. What this is asking us to do is not to use this custom comparator, but you can notice that the big difference here, we're passed in a vector of students. How do we sort things that don't, that aren't integers or strings that have a defined sorting method? Well, that's up to you. And so how you can do this is you can actually implement this manually using these operator overloadings. So here, what we could do, you can see a similar thing here with this equals, right? Where it basically returns equal if the IDs and the names are the same as another student. Here, we're just going to sort the students by increasing ID. So we have this less than operator. And again, the sort function by default uses that less than operator. That's what we talked about before when we were doing the lambda. So we have a student with an ID, and we have a passed-in student with an ID. That's on the right-hand side, right? So we have a left-hand side, right? And we want to know if it's less than a right-hand side. So what we can do is just, this. All this is doing is checking if, since we're sorting by ID, seeing that the left-hand side's ID is less than the right-hand side's ID. If this is the case, we return true. We think that the student itself is less than that student on the right-hand side. If not, we return false. We think the student on the right-hand side is in fact less than the student on the left-hand side. And we just do that by comparing IDs. All right, let's run this code, see if it compiles. I've screwed up my lambda expression. Do need a semicolon there. I've screwed up my thing because this is called students instead of nums, and I copy pasted it in my haste. See if it compiles. This one, sure. Okay. And then let's see if it submits. Hopefully I haven't made a silly mistake. It looks good. All right. There you go. Just some simple implementations of that sort method for you to, maybe exploit in your code here and there. If you have any questions, feel free to contact any of the TAs on Slack. And regardless, good luck with your coding and with the assignments in the rest of this class.